On September 12th, 2025, the universe delivered something no one expected. Astronomers spotted a colossal object streaking in from deep space. Its tail stretched 5 times the width of a full moon, dwarfing anything seen since Oumuamua. Within hours, the impossible became even stranger. A second visitor was confirmed. Both objects, racing toward the sun, set to make a close pass just weeks apart, yet arriving from opposite corners of the sky. The odds of such a cosmic double entry? Astronomical, according to the experts. The official line called them twin comets. But when the data came in, the story shifted. The evidence didn't just suggest something natural. It pointed to something deliberately engineered. So, what exactly entered our solar system in 2025? A freak accident of timing, or the first move in a secret operation triggered by us? It started with the solar heliospheric spacecraft. On September 12th, the SWAN instrument recorded a brilliant new object. It wasn't faint or hard to see. This thing blazed across the sky with a tail nearly 2.5 degrees wide, 5 times bigger than a full moon. For a new comet, that kind of scale was unheard of. The brightness registered at magnitude 7.4, clear enough for small backyard telescopes. Within hours, the news spread to amateurs across the globe. Forums lit up. Astronomers scrambled to confirm what satellites had picked up. In Australia, a hobbyist captured an image so long and dramatic it barely fit the frame of his camera. By September 13th, the International Astronomical Union made it official. The object was designated C/2025 R2, with SW added in recognition of the instrument that first spotted it. But people weren't calling it by its catalog name. It was already gaining a reputation. To some, it wasn't just another icy traveler. It was a force rewriting the rules of the solar system. The disbelief was justified. Most modern comets are faint, almost invisible, without powerful equipment. But SWAN, as it came to be known, dominated the night sky. Its tail cut through Virgo, stretching further each day, brighter and brighter. This wasn't just another icy snowball drifting in from the dark. This was something bigger, faster, and more vivid than anyone expected. But SWAN wasn't arriving alone, and that's where the mystery deepened. Just days before SWAN appeared, astronomers were already tracking something else. Another object, inbound from a completely different sector of the sky. This one was labeled Atlas. SWAN's path traced back through Aquarius. Atlas entered from Sagittarius. On a star map, their approach vectors were separated by more than a quarter of the celestial sphere. Yet, unbelievably, both were set to reach their closest approach to the Sun, perihelion, within the same 10-day window. For SWAN, the moment would come around October 20th, at 150 million kilometers from the Sun. For Atlas, October 17th, at 203 million kilometers. That's just 3 days apart, with their perihelion points closer than Mars ever gets to Earth. The geometry was staggering. Both were on steep, inclined orbits. SWAN tilted more than 60 degrees off the ecliptic. Atlas nearly perpendicular. By chance alone, the odds of two objects crossing the inner solar system almost simultaneously at such similar solar distances are vanishingly small. Random arrivals scattered across months or years. That's what astronomers expect from comets and interstellar bodies. But here were the two brightest new objects of the decade, converging on the Sun together. Coincidence? Or something far more deliberate? And then came the twist. Just as SWAN and Atlas reached their closest approaches, Earth would be blind. From October 8th to 18th, Earth's view of the sky near the Sun is blocked by its glare. This solar conjunction creates what astronomers call a blackout window. During those days, ground-based telescopes simply can't observe. And it was precisely during that blackout that SWAN and Atlas made their closest passes. Both at once, both hidden from Earth. To many, this was a red flag. Was the timing natural, or was it engineered to conceal whatever was about to happen? Because when observations resumed after the blackout, the anomalies began to stack up. Atlas wasn't famous for its brightness at first. What caught attention was its chemistry. Early spectrographs showed a shocking result. Atlas seemed dominated by nickel, with almost no iron. That defied everything known about comets, which nearly always show iron-nickel blends. Some labs thought it was an error. Others ran checks. But the nickel-heavy signature persisted. Then came the gas ratios. Instead of classic water vapor plumes, Atlas's coma spewed carbon dioxide, 5 times higher than H2O. The CO2 line at 4.3 microns drowned out everything else. Rare, but not impossible. Still, something didn't add up. The behavior of its tail sealed the debate. Observers logged 3 distinct accelerations. Not gradual, like normal outgassing, but sudden bursts. Each came about 2 weeks apart, each with a sharp color shift in the tail. On July 29th, a pulse. On August 14th, another. With each, the brightness spiked, then faded, almost as if Atlas had fired a thruster. Data poured in from independent observatories. The timing matched across the board. The effect was too clean, too controlled, too repeatable. Researchers began calling it thrust mix modulation, the tail's composition shifting in sync with its accelerations. And then came the power estimate. To produce the accelerations observed, Atlas would need an energy source outputting around 10 gigawatts. That's the equivalent of 10 large nuclear power plants, far beyond what an icy rock can manage. Mainstream scientists still argued natural causes, but the gaps in the data left the engineered object theory alive. If Atlas wasn't just a comet, what was it? The answer might lie in its companion. If Atlas broke the rules, Swan shattered them. Its tail stretched 2.5 degrees. Its brightness rivaled the greatest comets of the past century, and estimates suggested its energy output could reach 10,000 gigawatts, more than Earth's entire power grid. But it wasn't just size and scale. It was what the data hinted at beneath. Swan's reflectance patterns weren't normal. Amateur spectroscopists argued its core reflected light like metal, specifically a nickel-cobalt blend, materials prized on Earth for their strength and corrosion resistance. Some called it a hull. Then came the halo. Observers reported a shimmering, silvery glow around Swan's nucleus, fluctuating in intensity. To some, it looked like a plasma envelope, a shield capable of deflecting solar wind and cosmic debris. That's when the nickname the Fortress took hold. Unlike Atlas, the drone, quick and agile, Swan seemed more like a tank, immense, steady, and indestructible. Its tail wasn't smooth either. Micropulses rippled through it, rhythmic, precise, like course corrections. Each pulse registered as a small blip in brightness, and then the orbit. Swan's path would carry it around the sun once every 22,554 years. The last time it came close, Earth was in the grip of the Ice Age. If this object was engineered, it had been on a preset course longer than human civilization has existed. But why arrive now, alongside Atlas? That's where the mission theories began. 2 anomalous objects, one on a cycle longer than humanity's history, the other on a hyperbolic, maybe interstellar path. Both arriving within days, during a blackout window that prevented observation. Chance or mission? Some theorists suggest a scheduled refueling run. Both Swan and Atlas could be probes designed to recharge near the sun, harvesting solar energy or magnetic fields. The sun, after all, is the ultimate power source. Others see a less peaceful plan. A rendezvous to recover a malfunctioning unit, or worse, to neutralize it. If Atlas is a drone, Swan could be the fortress sent to intercept. Then, there's the audit chain theory. Oumuamua in 2017. Atlas now. Swan next. Each probe more advanced, sent in response to Earth's century of radio transmissions. A gradual escalation, checking in, testing, observing. Whatever the mission, the timing was too perfect to ignore. But the story didn't end with mission theories. It reached back into the deep past. Swan's 22,554-year orbit brushes against the last ice age. Around 20,000 BCE, glaciers covered much of the northern hemisphere. Ancient peoples were carving their first monuments, watching the skies, telling stories of fire and light. At Göbekli Tepe in southeastern Turkey, one of the oldest known human sites, stone pillars carry carvings of animals, symbols, and sky motifs. Some researchers argue the symbols may record comet paths, perhaps even marking the return of an object like Swan. Mainstream scholars call it speculation. But the timing is eerie. If Swan's orbit brought it through 22,000 years ago, it would have been visible during the exact era when those monuments were built. Coincidence or memory carved in stone? Either way, the echoes of Swan's cycle add a mythic resonance to its reappearance today. As Swan and Atlas approached their closest point, blackout orders went out. Officially, solar conjunction meant observatories paused operations. Unofficially, leaks revealed more. Space Command and the European Space Agency issued instructions. Suspend radar, cut high-resolution imaging, delay public data releases. Some requests for alternative coverage were denied outright. Internal reviewers were told, no statements until after perihelion. It was silence at the most critical moment. But not everyone followed orders. Amateur astronomers didn't stop. Bill Gray, an independent tracker, rallied a global network. Backyard telescopes, small observatories, even repurposed weather satellites joined the hunt. Encrypted forums and open-source channels filled with data, snapshots, calculations. With official voices silent, it was the grassroots network that carried the torch. The blackout wasn't just a problem, it was a challenge, and it turned ordinary stargazers into the only line of defense against a total information vacuum. If the first signals of Swan and Atlas re-emerging come from a backyard scope, not a government lab, the world will know who kept watch. Two colossal objects, one bright, armored, and fortress-like, the other smaller, agile, and pulsing with strange bursts of energy, both entering together, both hidden by the sun during their most critical moments. The official line says, comets. The evidence points to something more. Maybe a mission, maybe a warning, or maybe the start of something we can't yet explain. Because if these are not just comets, but engineered visitors, then their timing is no accident. They've come now, after millennia, during our age, when we finally have the tools to notice them. The question is no longer whether they're here. It's why, and the answer might change everything.